This video aims to explain the details of the implementation of the SIP mobility demo shown in the previous video. Let's recall the objective and the reference scenario. A mobile node with UMTS and wireless LAN interfaces will be able to switch the communication between its two interfaces. The switching procedure is controlled by the Session Initiation Protocol, or SIP. The architecture implemented for this demo comprises one laptop acting as a mobile node with wireless LAN and UMTS interfaces. The laptop is running a modified version of the Kphone software as a SIP client. Then we have one of the Extreme PCs equipped with an 802.11 card in access point mode, acting as an access point of a wireless LAN configured in infrastructure mode. We are also using the Extreme Cellular System architecture as a UMTS network. One of the PCs in the Extreme cluster has been programmed with the SIP Express Router software to act as a SIP server. And finally, we have another Extreme PC running the Kphone application that acts as a correspondent node. Now let's describe the implementation and operational details. We will just focus on the handoff from UMTS to wireless LAN for the sake of brevity. In this explanation, we are also assuming that the Kphone clients, that is, that of the mobile node and that of the correspondent node, have already registered their current IP addresses in the SIP server. First of all, the mobile user starts his voice over IP communication with the correspondent user. To do this, he writes the correspondent user's SIP address in the Kphone. Invite and OK messages exchanged by the two users are traveling through the UMTS network according to the legacy SIP multimedia session establishment procedure. We don't enter the detail of this procedure since it is not the core of the SIP mobility demo. Now the voice over IP communication is established and the users can start talking. We can confirm that traffic is traveling through the UMTS interface looking at the monitor of the Extreme Cellular System architecture. At a certain instant of the communication, the mobile user decides to switch from UMTS to wireless LAN, for example, because he entered his house in which an internet connection is assured by a wireless LAN access point. So, his voice traffic has to be redirected to the wireless LAN interface of the mobile node. To do this, the user clicks on the Kphone button to trigger the change of interface. When the user clicks the button, a signaling procedure starts in the heterogeneous network. Let's describe this procedure in detail. An invite message is sent through the new interface of the mobile node, that is, through the wireless LAN interface. Looking at the invite message captured during this phase, and more in particular at the IP address written in its header, we can confirm that it is passing through the wireless LAN. When the correspondent node receives the invite message, it sends an OK message to the mobile node to acknowledge that the invite message has been correctly processed. As we can see from the Wireshark capture, the mobile node is receiving the OK message through its wireless LAN interface. Even in this case, looking at the IP address field, we can confirm this. Finally, the ACK message from the mobile node closes the procedure. It is worth noting that during this procedure, a register message is also sent by the mobile node to the SIP server to communicate the change of the IP address in which it is reachable. Now let's take a look at the components of the vertical handoff delay. We can distinguish three parts in the vertical handoff process with their respective delay. First, we have the interface switching delay, which is the time between the transmission of the last packet through the old interface and the invite message sent by the mobile node through the new interface. Then there is the delay due to SIP, that is, to say the time of the invite OK ACK message handshake between the mobile node and the correspondent node. Finally, we have the communication re-establishment delay, That is, the delay between the reception of the ACK message and that of the first packet sent by the correspondent node to the new interface of the mobile node. Now that the vertical handoff procedure is finished, the traffic can travel through the wireless LAN interface of the mobile node. We can actually see that traffic sniffing the wireless LAN network.